So I'm going to do the first task in exercise 2 on Codility. It's called Rectangle Builder Greater Area. Okay, so the idea of this exercise is we've got to build a sheet pen out of a number of fences. And we're given an array here describing the fence lengths. We need to build a rectangular pen for sheep using these fences. We're also given another integer value, which is the area that the pen needs to cover. So in this example, we're given fences of length of 1, 2, 5, a couple of 1s, a 2, a 3, a 5, and a 1. And x in this example, the area that we need to cover is 5. So we can build two different pen sizes. Either we can build a 1x5 because we've got 2 5s and 2. We've got more than 2, but we've got 2 1s, so we can build a 1x5. Or we can build a 2x5 because we've also got 2 2s. And those two are the only way that we can build a pen with an area greater than 10. The solution needs to return the number of different pens we can build, so the answer is 2. N is an integer in the range of 0 to 100,000, so that's how many different fence lengths we're given. X, which is the area, is an integer within the range of 1 to 1 billion, and each fence length is an integer within the range of 1 to 1 billion. Because our pen needs to be rectangular, we need to have matching opposite edges. And now we can build square pens as well, where we would have, for example, 2x2 or 3x3. Obviously we still need to cover the area specified in X. But because we need to build rectangles, I'm only really interested in edges where I have more than one. So for example, this 3 here, I've only got one of those, so we're not going to be able to use that at all. So the first thing I want to do is count up the fences for all the different lengths that I've got. So here I've got lengths of 1, and in there I have 1, 2, 3, 4 fences. Of length 2, I have 1, 2 fences. Length 3, I have 1 fence. Length 4, I don't have any. Length 5, I have 2 fences. And then I'm only really interested in lengths. So I'm not interested in the 3 because I only have one of those. I'm only interested in lengths of 2. And also lengths of 4 where I can build a square. So the first thing I'm going to do is count up these fences. So I'm going to start by preparing the class with the example in the exercise. Okay, so there's our list of fences, and this is the area we're looking for, 5. So now let's count up the fences. Okay, so I'm going to start by having a hash map fence counts, and that's going to count the fences of the different lengths. So the key of the hash map will be an integer, and that will be the length of the fence, and then the value in the hash map will be the number of times that we've seen that fence. And then I'm going to work through the array, and fence counts, I'm going to put the count in there for this length of fence. Now I'm going to say fence counts get, if fence counts get A is null, I'm going to put 1 in there. Otherwise, I'm going to put the value that's already in there plus 1. And at this point I'm going to make a list of fences that we are going to be using in the next step. That's just an array list. Just do the inputs there. And if at this point, if fence counts get A equals 2, we are going to be using this fence. So I'm going to add it to the fences list. Now I'm going to deal with square fences now. So I'm going to make my counter now. I'm going to call it pens, initialize to 0. So this is the result that we're going to return at the end. So I'll just return pens at the end. And if fence counts equals 4, then we can build a square fence with it. But I need to check if A times A is greater than or equal to the area we want. If it is, we have a pen. Now I'm going to have to be careful at this point, because in the exercise description it says that the maximum length, or the maximum fence length, is 1 billion, and if we do 1 billion times 1 billion, that's going to overflow an int. So 1 billion times 1 billion is not necessarily going to be greater than the area, even though it really is. So what I'm going to have to do is cast one of the values to a long, so the calculation is done as a long, and that is going to make sure we don't overflow the int there. So what we should now have is the number of fences that we can create as a square created. Okay, so now I've got my any square pens that I can create already counted. Now I just need to look at pens where the length and the width is different. So I've got my list of fences, which are fences that we're going to use because we've seen 2 of them. If we've seen more than 2, if we've seen 3 or 4 and used it for a square, we've still counted it when we saw 2. So that list in this example should consist of 1, 2 and 5. Now the first thing I'm going to do is sort that list, so we know for sure that the order is 1, 2 and 5 in this example. So this is our fences list. Now I'm going to create an index, a short index and a long index. Now the short index is going to point to the shortest side, and the long index is going to point to the longest side. I'm going to start them off pointing at the same list. Now I'm just going to create a better example to work with here. I'm going to say my fences list consists of numbers from 1 to 6. So in the previous step we've seen at least 2 of each of these values. I'm going to say x equals 8. Now I'm going to create a short index and a long index. Now the short index is going to point to the shortest side that we're considering, and that's going to start off at the first place. So this is short index. The long index, I'm going to start off at the top place. So the long index is going to point to the top side. And what I'm going to do is I'm going to loop through for the short index from the bottom going up. I'm going to move the long index down if the area of the short index multiplied by the long index is greater than or equal to our area that we're looking for. So we start off with a short index at 1, a long index at I. We take a look at 1 times 6, it's less than 8. So we don't do anything in that loop, but we move the short index up. We then look at 2 times 6, that's 12, so it is greater than 8. We move the long index down. Then 2 times 5 is 10, is greater than 8. We move long index down. 2 times 4 is 8. If it's greater than or equal to, we move long index down. 2 times 3 is 6. It's not greater than 8. So we stop moving long index down. Now we count how many steps long index is down from the top. It's 1, 2, 3 steps down. We add 3 onto our number of pens. In the next loop, we move short index up. Now I'm never going to move long index below short index because it says in the description that a pen of 1 times 2 is the same as a pen of 2 times 1. So we'll always keep long index looking at the long side, short index looking at the short side. We've moved the short index up. We don't need to move long index back up again because we know that all of these values multiplied by the lower value did exceed the area, so we know by moving the short index up that it will still exceed the area. So this one was for short index equals 2, and then for short index equals 3. We count how far long index is away from the top again, it's 3 again. So we add another 3 onto our pens. Then we move short index up. Now if short index goes higher than long index, we want to move that up again. So now for short index of 4, long index is 2 from the top. So we add 2 onto pen. For 5, long index is now 1 from the top, so we add 1. And finally for 6, long index is at the top, so we don't do anything there. Okay, so the first thing to do is sort our fences. And then I'm going to create my long index, which is going to start off at fences size -1. So that's at the top end. And my short index, I'm going to start off at 0. And while short index is less than fences size -1, so while short index has not reached the end, I'm going to do an inner loop for the long index. I say while short index is less than long index, and now I need to cast to along again because I'm checking the area. So while fences at short index times fences at long index is greater than or equal to x, so while a rectangle with the fence at the short index multiplied by fences at the long index is greater than x, then I move long index down. And then the number of pens we want to count is fences size -1 minus long index. So that's how far long index has moved down from the top. Now one other thing I need to do, which it said in the description, is if the number of pens exceeds 1 billion, then I need to return -1, and I'll do that here. And then finally I need to move short index up. Now I can't let long index go lower than short index, so to do that I'll say long index equals max.max what it is and short index. So if short index moves up, long index goes with it. And finally we return pens. Okay, so let's just run that and see. This is on the exercise, we need to see 2. We can see 2, and let's very quickly debug it and see what's happening. So we start off with fence counts empty and fences empty, and then we work through our A array. So the first one we see is a 1. Put that in fence counts, we've seen 1 1. It's not 2 and it's not 4. The next one we see is a 2. Put it in fence counts, we've seen 1 1 and 1 2. It's not 2, we haven't seen 2 and we haven't seen 4. The next one is a 5. So we go through and we count the 5. The next one we see is a 1. Now that is a 2. We've now seen 2 1s, so we add it to our fences list. The next one we see is another 1, so that goes up to 3 lots of 1 that we've seen. The next one we see is a 2. So now we've seen 2 lots of 2, we put it in our fences list. The next one we see is a 3. We count our first 3. The next one we see is a 5. We've now seen 2 5s, so we add that to our fences list. And the next one we see is a 1. Now we've seen 4 1s, so we've got 4 of those, so we consider it as a square, but 1 times 1 is not greater than the area that we want, 5, so we don't count it as a pen, so pen stays at 0. Now we can forget all about fence counts now. We've got our fences and we've got at least 2 of each of these lengths, 1, 2 and 5. It's already sorted, but it might not be, so we sort the list and we have 1, 2 and 5. Long index is 2 and short index is 0, so long index is pointing at the 5, short index is pointing at the 1. Now the area that we're looking for is 5. So 1 times 5 will do it, so we should move long index down 1. But the next one we'll look at is 1 times 2. That won't do it, so we won't move long index down any further. And fences.size -1 is 2. Long index is currently at 1, so it's moved down 1. So we want to count the pen, and the pen we've just counted is 1 times 5. We haven't overflown the billion. We move short index up, and now we've dealt with the 1. The only thing we now are looking at is the 2 and the 5. Long index is pointing at the 2. It can keep pointing at the 2. Now, can we move it down again? So they're both pointing at the 2. It can't move it down again because short index is not less than long index, so we don't move it down again. Now this is the thing about not having to put long index back up. We know that 1 times 5 worked, so anything times 5 is going to work. Anything higher than 1 times 5. So we can just count how far long index is down from the top, which is another 1. So that's our second pen, and we've counted 2 times 5. We still haven't exceeded the billion. We move short index up again, and long index goes with it. So now they're both looking at the 5. Okay, short index is looking at the top. We would have already counted it as a square if we had another 5. So that's it. We've counted 2 pens, and that's my solution. So I'm going to submit that in Codility. And 100%. So that's my solution to Rectangle Builder Greater Area. Thanks for watching.